All last week we spent dealing with and figuring out how to divide polynomials. So we did long division, synthetic division, and then we spent some time talking about the remainder and the factor theorem. And so this first note sheet, or this lesson 2 note sheet, reminds you what the remainder theorem is. And so if we take a polynomial and we divide it by another polynomial, a linear factor here, then the remainder is that particular function value. And so we're dividing by x plus 2. So if we find that 0, that would be x equals negative 2. And so this function, when I evaluate it for negative 2, is the remainder of negative 20. All right. The factor theorem comes in two parts. You can either do it as a function value, or you can do it as division. If you divide by a linear factor, which also means you could replace x with r, if you end up with a function value of 0, then what you divided by, in this case x minus r, is a factor. Or if you do division and you end up with a remainder of 0, then again, what you were dividing by is a factor. So we're going to use the factor theorem and the remainder theorem to solve some problems. So this first video is going to go through questions 1 through 4. And so the first two questions say to determine if x minus 2 could be a factor of the function, show work. So I'm going to zoom in on question number 1. And basically, I'm going to do this with a little synthetic division. So I am going to start by finding the 0 of my factor. So x minus 2 is equal to 0, which means x is equal to positive 2. I'm going to set up a synthetic division problem using that positive 2 and then the coefficients of f of x. So I'm going to pull 8, negative 16, negative 7, and 14. Little workspace here. First number drops straight down. So there's 8. 2 times 8 is 16. Add them up vertically. That's going to be 0. 2 times 0 is 0. Add it up vertically. Negative 7. 2 times negative 7 is negative 14. And if I add those up, that's 0. Now, this last value is my remainder. Because my remainder is 0, yes, x minus 2 is a factor of f of x. Had to look at what the notation was. So the answer is yes. Okay, as long as you divide accurately and you get a remainder of 0, you have a factor. I believe question number 2 asks the exact same thing. It does. It asks, is x plus 1 a factor of the function? So let's go ahead and figure this out. So I'm going to take my factor, what I'm checking for, set it equal to 0. And so that's going to give me a function value or 0 value of x equals negative 1. So negative 1, and let's do a little synthetic division here. I just need the coefficients. So 3, negative 3, negative 2, and a 2. And if you remember when we did synthetic division, we want to make sure that we don't need any placeholders. So this was x cubed, x squared, x, and then the constant. So no placeholders needed. First value drops straight down. So that's going to be 3. Negative 1 times 3 is negative 3. I'm going to add those up. Negative 6. Negative 1 times negative 6 is positive 6. Add those up. I'm going to get positive 4. Negative 1 times 4 is negative 4. Add those up. I get negative 2. So my remainder is negative 2. So the answer is no. X plus 1 is not a factor of f of x. Now, it doesn't matter what the remainder is if this remainder is anything other than 0, then this is not a factor of what you were working with. Okay, so it's that simple. So that's problems number 1 and 2. You can actually test using synthetic division and the remainder theorem or factor theorem, however you want to look at it, to find out if you have factors. All right, problem number 3. Use the factor theorem to determine the unknown coefficient a if x plus 3 is a factor of f of x. Now, I'm going to show you 2 different ways to do this because I know problem number 4 is the same type of question. So for problem number 3, I'm actually going to set this up as synthetic division. So I'm dividing by x plus 3. That's my factor. I'm going to set it equal to 0, and I'm going to get x equals negative 3. So I'm going to set up some synthetic division here. Now, when I pull the coefficients, I got x cubed, x squared. Now, this is going to look a little weird, but I'm going to use that negative a as a coefficient and then negative 6 as my constant term. So no placeholders needed other than the variable that we are working with. So negative a and then negative 6. Here's a little workspace. All right, first number drops straight down. There's my 7. Negative 3 times 7 is negative 21. Add vertically, that's 0. Negative 3 times 0 is 0. Add vertically is negative a. Negative 3 times negative a is going to be positive 3a. I know this is looking weird. All right. And we're going to add these up. So 3a plus 6. Now, I know that doesn't look like you just solved the problem, and we're not quite there yet. But here's what I do know. I know that x plus 3 is supposed to be a factor. So I know my remainder, all right, that's my remainder, is supposed to be equal to 0. So I'm going to set that up. I'm going to say that my remainder is equal to 0. So that's equal to 0. So I'm going to subtract 6 from both sides. So 3a equals negative 6. Divide to solve, and I'm going to get a equals negative 2. Except I just realized I made a mistake. All right, for anybody yelling at the screen going, hey, Miss Curran, you added wrong, you're correct. Negative 3 plus a negative 6, that's supposed to be a negative. So let me take that out, which is going to change up my math just a little bit here. So that becomes a negative, which makes that positive, positive. All right, sorry about that. This is why you check your work. All right, so a equals 2 is the answer to the unknown coefficient. So that's how you do this problem using synthetic division. And remember, I've said with these problems, sometimes it's going to specifically say in the question that you have to use synthetic division. So make sure you understand how to do that. And that's this particular problem. Okay. Problem number 4, same type of question overall. Okay, I am telling you that x minus 5 is a factor of this function, and we want to determine the value of a. Now, the other option here, the other way you can do this problem, because it doesn't specify, you can start off the same way. So x minus 5 is equal to 0, so x is equal to 5. One of the deals with the factor theorem says that if this is a factor, then the function value when x is equal to 5 has to be 0. So what I can do is I can actually put f of x and replace this with f of 5, because that's the function I'm working with, or that's the factor I'm working with. And I'm going to set this equal to 0. So 0 is equal to, and I'm going to replace all of my x's with 5's. So 5 cubed minus 9 times 5 squared plus a times 5 plus 60. Now, I want to simplify this. So 5 cubed is 125. 5 squared is 50 times 9. I think that's 450, but I want to double check. Nope, that doesn't sound right. 5 squared isn't 50. 5 squared is 25. All right. So that would be minus 225. plus 5a plus 60. So let's combine some like terms here. So 125 minus 225 plus 60. So a is equal to negative 160 plus 5a. I'm going to add 160 to both sides. So 160 is equal to 5a divided by 5. I always run out of space with these problems just because I write so large. All right, so I'm getting a is equal to 32. So that's one of the other ways to do this problem. So you can, if no directions are given, you can pick or choose. Either do synthetic division and figure out that your remainder has to equal 0, or do the function notation, set the whole thing equal to 0 when you evaluate at the 0 of your factor. It's really up to you for which one makes more sense if the directions don't say otherwise. All right, I'm going to go ahead and close this video out. I'm going to make up 2 other videos for the rest of this sheet so you can kind of pick and choose what you need to look through. If you have any questions or concerns, please let me know and I will help you out as best I can.